Hey, pre-calc. So here's the do now for you. You got two functions pictured on the same graph. The red one, that's the original, and the green one has been transformed. There's two transformations. I want you to describe those transformations first, and then give me the function notation which would indicate each of those two transformations down below by filling in the appropriate A, K, C, and or D. Ready, go! All right, nice job. Well, the two transformations you see there, the green graph has been slid to the left by 2 spaces. Also, there's a vertical shrink. The green one is half as tall as the original red one. You can see that in a couple of different places. The point with the blue outline is one place where we can see that. And the red original function has got that point has a coordinate for the y coordinate of 1. And in the green transformation, that corresponding point is a y coordinate of a half. And you can see that in all the other points as well, but that's the one I pointed out. So for transformation number 1, sliding to the left by 2 spaces, that's going to give us a C value of plus 3. And for the vertical shrink by a half, that's going to give us an A value of 1/2. So today we're looking at function transformations to be able to transform the coordinates of points. And we got these same notes that we had from last time. Here's our transformation notes page. And today what we're going to look at is what happens if you've got more than one transformation going on in the same function. So there's two possible cases here. The first is if you have more than one transformation affecting the same coordinates, like two different transformations both affecting the x coordinate, or there could be two different transformations or three different transformations affecting the y coordinate. In that case, we have to follow the order of operations, which for the transformations we're looking at means multiplication first, and then either adding or subtracting has to happen second. Of course, there's more to the order of operations, but those are the only things, those are the only operations that show up in our transformations. If you have transformations which affect different coordinates, like you got multiplication on the y coordinate, like we saw in the do now, and adding on the x coordinate, it doesn't make any difference what order you apply them because they're affecting different coordinates. So it's just in the case where you've got multiple transformations affecting the same coordinate, we've got to follow the order correctly. So let's do some examples. So this example, we got function example B. So we've got three different parts, what you see on the screen here. So let's just narrow this down so we can identify what you see on the screen. So upper left, that's the function notation describing a transformation. The right-hand side, there's our original graph, points A, B, C, and D. And then the lower left, we've got a table of values with the coordinates of the original points A, B, C, D. And in the next column over, we're going to write the new coordinates for those 4 points. Right? So that's what's going on here. And it's overwhelming. It's like, oh, there's so much stuff on the screen. So let's look at the function notation to identify the transformations that are happening here. So I've got in green there a 1/2. That 1/2 is being multiplied onto the x inside the parentheses. And if we can't remember what that does, we can always go back to our notes page and look for something multiplied onto the x inside the parentheses. So here's multiplication, but that is, I'm looking in the center column there. This one is being multiplied outside the function notation. And here's what I'm looking for. Inside the parentheses, that k number is being multiplied onto the x. So this is going to be a horizontal stretch or compression. How do I know which one it is? Well, I look at the k value. I want to know if the k value is less than 1, like it is in our problem here. It's a half. That's going to stretch the graph wider. And what do I do to find the new coordinates? Well, I need to take that k number, get the reciprocal, which in this case, the reciprocal of a half is 2, multiply that onto the x coordinate, and that'll give me my new x coordinate. All right, so let's bring that information back to our problem here. So this green 1/2 is going to affect the x coordinate only. It's a transformation on the x coordinate. We see that's inside the parentheses. I'm going to take the reciprocal of a half, which is 2. So I'll be multiplying those x coordinates times 2. And the effect I will see on the graph is this going to be a horizontal stretch. The other transformation is this -4. inside the parentheses again, and on our notes page, again, we probably want to start from the top. Right there it is. Inside in the center column here, inside the parentheses, the x minus some number, it's going to give us a horizontal translation where we slide the graph towards the right. And on the coordinates, we see this again affects the x coordinate. I'm going to do the opposite operation. The function notation says minus. We need to add that c value to the x coordinates. X coordinate plus 4 slide right. All right, so the process, we want to, just to summarize the process, is we're going to look at the function notation, identify each of the various transformations which is present, and most importantly, the first thing we need to identify is which coordinate it's going to affect. Both of these two transformations affect the x coordinate. The green one is multiplication, the blue one is addition. I need to follow the correct order of operation in order to make the transformation onto the coordinates correctly. So I'm going to take each of these points. Let's just get this set up and get some parentheses for my coordinates. And the x coordinate for our point A is -6. I'm going to multiply by 2, then add 4. And I need to do it in that order. Otherwise, I'm not going to get the right answer. If I do the addition by 4 first, it's going to be a different answer. So -6 times 2 is -12, plus 4 is -8. For point B, -3 times 2 is -6, plus 4 is -2. For point C, it'll be -1 times 2 is -2, plus 4 is +2. And for point D, 2 times 2 is 4, plus 4 is 8. And then the y coordinates remain exactly as they were before. There is no transformation that affects the y coordinate here. So -2, 3, 0, and 2. We can go ahead and plot those points. So we've got point A prime at -8, -2. Point B prime is at -2, 3. C prime is going to be at 2, 0. And D prime is at 8, 2. Shoop, doop, doop. Okay. So this is what our graph looks like. So I've done the whole problem here. I got my new coordinates. I listed my coordinates in the table, and I've got the graph sketched over here onto my graph. Okay, so I'm going to play around with the graph a little bit here. If I take the original function and just do the green transformation, if that's the only thing I've done, I'm going to make it twice as wide, then that's going to look like this. You can see on the screen right now. So each of those points is going to be twice as far away from the y-axis. That's what our width is really describing. It's not just end to end. I mean, the end to end width is twice as much, but really each of those points moves twice as far away from the y-axis. And so we can see that here. There's the width, and then if I add on to that the second transformation, the blue one, where I also slide to the right 4 spaces, sliding 4 spaces, then it's a little bit obscured, that width being twice as big. I mean, you can still see that the whole shape of the graph is twice as wide, but exactly how we got there is a little bit lost in translation that way. So just as an illustration, you don't need to do anything like that. All right, let's check another example. So on this problem, I've got a negative sign out in the front of my function notation, negative f of x, and then -3. So the green transformation, that is going to affect the y coordinate, and this is a reflection. It's going to reflect across the x-axis, so anything that's up is going to end up being down. Anything that was down is going to be up. And so I'm multiplying by -1. That is the operation I'm going to carry out on the coordinates. Okay, the blue one also is going to affect the y coordinate. Lost my c in there. And this is going to slide the graph down 3 spaces. And the operation is I'm going to subtract 3. So again, you can go to the notes page and match each of those transformations up if you can't remember what it is that they do. The y coordinate transformation is very much straightforward. It says, make it negative, you make it negative. It says -3, you subtract 3. So since all of these transformations only affect the y coordinate, we can go ahead and just fill in the x coordinates to start with. And then in order to carry out the transformations on the y coordinate, we are going to have to follow the order of operations. So the green one, multiplication by -1, so that has to happen first, and then the blue one, which is subtraction. So multiplication always first, and then either addition or subtraction. So point A, we had -2, we multiply that by -1 is +2, then subtract 3 is going to give me a -1. This is going to become, was +3, it's going to become -3, and then I subtract 3, so that'll be -6. For point C, there's no such thing as -0, but it's a 0, and then subtract 3 gives me -3. And for point D, 2 multiplied by -1 is -2, and then subtract 3 is going to be -5. So my points, -6, -1, that's A prime, and -3, -6, that's B prime, -1, -3, there's C prime, and then 2, -5, there's D prime, shoop, shoop, shoop. Okay, so you can kind of get a sense of what is going on. So this graph was reflected across the x-axis. So points B and D, which were above, have been reflected below the x-axis. Point C was on the x-axis, so that was not affected by the reflection. Point A was below originally, and because of the transformation, it is now reflected above. And then, so it would look, if we had just done the reflection, it would look like this. We lost a point. Whoops, this dot didn't get attached. All right, so there's just the reflection, would look like what you see on the screen right now. But then there was also the translation where we slid down 3 spaces. And so that gives us our final version. And you don't need to illustrate the steps along the way, but is just as an example, part of the demonstration, so you can see what's happening. So that's what this looks like with both transformations being applied. All right, so last example here. I've got, here's my function. It's got a little bit of everything in it this time. So -3 times f of 1/2 x plus 1 inside the parentheses plus 2. So I've got, looks like 4 different transformations. Depending on how we want to describe it, we could actually describe it as 5 different parts, but I'm going to deal with it as 4 transformations. So we've got a negative sign in front of the function notation. So that's going to be a vertical reflection. It'll reflect across the x-axis. I'm going to go ahead and combine that with the 3, that leading coefficient, which will be a vertical stretch to make this 3 times taller, or move all the points 3 times as far away from that x-axis. So if we're describing by names, those would be 2 separate names. But as far as the actual application onto the coordinates, -3 is, I just call it -3. I don't need to do negative and then multiply by 3. So there's one transformation. I've got inside the parentheses 1/2 multiplied by the x. That's my k value from my note sheet. And that is going to make this graph twice as wide. So I've got the horizontal stretch. I got the +1 inside the parentheses. That is a translation. It is going to slide this entire graph to the left 1 space. And lastly, I got the +2 outside the parentheses, which is again a translation. This one is vertical. It will move the entire graph up 2 spaces. So I want to, Mostly, I want to identify what these four transformations are done. So I got the -3. So it's going to affect the y coordinate. I know because I can either match it on my note sheet or even before I go to the note sheet. It's outside the function notation, so it's going to affect the y coordinate. I will be multiplying by -3. Multiplied by -3. Let's just call it times. That's easier to write. And it is both a reflection and a vertical stretch. Vertical stretch and reflection. Okay, the green one, this affects the x coordinate. I know that because it is inside the parentheses. I'm going to take the reciprocal of that k number, so a half. The reciprocal is going to be 2 over 1, so I'll be multiplying by 2. And that is a horizontal stretch. The blue one, inside the parentheses, is going to affect the x coordinate. I am going to be subtracting 1. So I have to do the opposite of the operation indicated if it's inside the parentheses. And the translation is to the left. One space. Okay, the last one, outside the parentheses, this +2 on my arrow is pointed the other direction. Whoops. So it's outside the parentheses. It's going to affect the y coordinate. I am going to add 2 in face value outside the parentheses. You just do what it says. It says +2. And this is going to slide that graph up 2 spaces. Okay, so I've got 4 transformations the way I've described them because I grouped that reflection and vertical stretch. And 2 of the transformations affect the y coordinate. 2 of them affect the x coordinate. Does not matter whether you do the x transformations first or the y transformations. I know some people are like, oh, parentheses, then order of operations, parentheses happens first. Does not make any difference whether you do the x or the y first because they're completely unrelated to one another. So I'm just going to go ahead and start by making some parentheses for my coordinates. And then I'll just do the x first because x is the first coordinate that shows up. So I need to follow the order of operations. My 2 operations for inside the parentheses that affect the x coordinates, multiply by 2 from the green one, and then subtract 1 from the blue one to times 2 and then -1. So I'm going to take the x coordinate, which is -6, times 2 is -12, and then subtract 1 will be -13, which is not going to fit on my graph. That is all right. -3 times 2 is -6, -1 is -7, -1 times 2 is -2, -1 is -3, 2 times 2 is 4, -1 is +3. Okay, now let's move to the y coordinates. So I have, again, 2 different operations that need to, from the one I highlighted in yellow and then wrote in black, multiply by -3. I need to do that first. And then the purple one is adding 2. So times -3 and then add 2. So -2 times -3 is +6, and then +2 is 8. And for point B, times -3, that's -9, +2 is -7. 0 times -3 is still 0, +2 is 2. 2 times -3 is -6, +2 is -4. All right, so that -13 is in point A is going to be off the edge of my graph. If I choose the right color here, we'll still be able to see it. I'll approximate. So -13, 8. -13, up here at 8. So right about here is going to be my A prime. B prime is at -7, -7. C prime at -3, 2. and d prime is at 3, -4. Connect the dots. Try to draw straight lines. Rulers are helpful for that. Okay, so we can see this is what the graph would look like. We can see each of those 4 transformations happening. The sliding down 1 space left 1 space and up 2 spaces is probably the easiest things to recognize. These other things are a little bit harder to see, but you can see point A. If we look at the first transformation, it was the yellow one, is to reflect across the x-axis. So point A was originally below the x-axis. It is reflected above, and also been stretched 3 times as far away from the x-axis. So it's going to be 3 times taller. And that's what we see. Point A prime, instead of being below the x-axis, is now above the x-axis. And instead of being 2 spaces up, it's more than that, right? And then also the purple translation slid that whole graph up 2 spaces. And so now its final resting place there at -13.8 is obviously more distance from the x-axis than what it would have been without the translation. Okay. So we could go through the same description for each of those points. Point B was started out above the x-axis and then is below, and then it was stretched further away from the x-axis. Point C stayed on the x-axis through the reflection and the stretch, but then as a result of the translation, still slid up 2 spaces, and point D originally was above and now is below, and then was stretched further below by that -3 leading coefficient. The green transformation, each of these points was stretched to be twice as far away from the y-axis, and then after that, the whole graph was shifted left by 1 space. So point A was 6 spaces to the left, and now is 12 spaces to the left because of the stretch, and then it slides 1 more space over. The same thing for the other points. And so we can think our way through, all of those transformations can actually be seen on the graph. But the finished product is we need the coordinates and we need that new graph.